Hey, this is Burkan from Next Startups, an online channel where startup founders can get practical advice on each part of their journey from idea to growth stage. In this video, I will be talking about how much it is going to cost you to host your MVP, an app or a website on Amazon AWS. It's a very tricky question and depends on a lot of different factors, but I will try to give in some specific price ranges. Please note some basic assumption for these costs. Number one, these are just sample costs and your final costs may vary. I will try to give a range rather than a specific price. Number two, all these prices are calculated assuming you are hosting with Amazon's data centers in Virginia. If you use a different data center, your costs will vary. Number three, that you are using basic free tier support plan with Amazon. Number four, you're not using Amazon's CloudFront. Number five, there is moderate bandwidth usage, that is not too many images or video streaming on your app or website. Number six, your app or website does not have a chat intensive or social networking feature where there's very high engagement at any given time. I will be doing a separate video on that. Number seven, you're ideally using node.js backend technology because it is very fast. You can use other technologies like PHP as well, but it's recommended that you use node.js. So if you want to know the basic architecture that I use for AWS applications, I would suggest that you check out my video on scalable AWS architecture. I have provided the link in the description. For this video, we will be only using 4 basic services from Amazon. Number one, AWS Load Balancer. Number two, the EC2 service. Number three, AWS RDS database and its multi-zone replication feature. And number four, S3 for images. For each example, I will be sharing a calculator link at the bottom so you can see the exact code in Amazon AWS cost calculator. The way it's going to work is that I'm going to let you know what services we will be using from Amazon, how many users it can support, and what kind of app or website this architecture or setup can support. So let's talk about our first architecture. As you can see that we are using 3 services in this architecture. One is the Amazon S3, which is basically Amazon's cheap service for hosting images. The second is EC2, which is basically Amazon's virtual dedicated servers. And number 3 is RDS, which is Amazon's database service. So for the S3, we have a bucket of 5 GB. We are assuming that you will have an expected load of 100,000 images per month downloads. For the EC2, we are using a single core, 1 gigabits of RAM and 8 gigabits of hard disk SSD. And for the RDS, we are assuming that you're using 1 core, 1 gigabit of RAM and 8 gigabit hard disk SSD. So let's see how many users or what it can support. So our use case is that this architecture can support up to 300 users at any given second, or in technical terms, concurrent users. Number two, it's ideal for around 500 to 10,000 users per month, assuming that your per second load at any given time is not more than 300 users. Number three, this architecture is not easily scalable. Definitely S3 is scalable because that's how Amazon service is designed. Whatever amount of downloads you use, Amazon sends you a bill for that. But we don't have a load balancer in this, so it's not easily scalable. With the DB part, there is automatic DB backup, but there is no fallback because of no multi-zone replication feature. If you want to know about multi-zone replication, do check out my video on RDS. So, what kind of websites do you support with this? You can support WordPress blogs, you can support SaaS websites or apps with less than 5,000 active users per month, and MVP where some level of downtime because of hardware or server failure is acceptable. So how much is this going to cost? It's only going to cost you $15 to $30 per month. You can find the link that I used to generate this code in the description for this video labeled as use case 1. Please note that Amazon AWS free tier support is included in this. So if you don't use that, or if you have already expired your first year code, the costs are going to be higher. Let's look at the second architecture that I have designed. As you can see that I have kept the Amazon S3 bucket the same size, 5 GB, with the assuming load of 100,000 image downloads per month. The second service that I'm using is called Amazon AWS Load Balancer. So the job of load balancer is to sit in front of your servers and distribute the traffic between your server, assuming that you have more than one servers. The amazing thing which you can do with load balancer is that you can make it a part of auto scaling group. So it can increase or decrease your servers depending on how much load is there on your existing servers, and attach it to the load balancer so it can start routing traffic to that. For this purpose or this architecture, I have kept 3 servers behind the load balancer with the same spec as last time. With the RDS, there is one addition this time, that there is a standby replica of the main DB. This is called the multi-zone replication feature. Amazon takes care of this automatically, so if your main server goes down for any reason, there is no latency. The traffic is automatically transferred to your replica. Meanwhile, Amazon is trying to bring up your main database. So this is a really good feature, and I love the RDS feature because of this one great feature. And it's my primary reason for using and choosing the RDS service and not hosting my own database on EC2 servers or creating my own cluster. So this is a big feature. So let's look into how many users this can support. So this thing can support easily 1000 users at any given second, or concurrent users. It is also good with anything up to 50,000 users and a cautious maximum of 100,000 users. This is easily scalable and can be set up to auto scale as the load increases behind a load balancer. The image part S3 is scalable. The DB has a standby replica. The main server goes down and the standby comes up automatically. You can support again SaaS websites or apps with moderate activity, and websites that can easily scale with more load. This again is going to cost you somewhere between $100 to $200 per month. You can see the link of how I came up with this cost in the Amazon AWS cost calculator. Let's look at the third use case scenario. In this scenario, I have increased the size of the bucket to 100 GB. I am assuming that it is serving 1 million image downloads per month. The load balancer is the same, the load balancer service, but it is set to auto scale between 3 and 6 servers. And I have increased the capacity of each server from 1 core to 2 core and from 1 gigabit of RAM to 8 gigabit of RAM. So now these servers can auto scale between 3 and 6 servers depending on how much per second load your servers are getting. And the RDS service is basically the same, with the bit change in the main RDS database that I've increased it from 1 core to 2 cores and 8 gigabits of RAM with a 50 GB hard disk. So let's look at what this architecture can handle. So you can see that this system is a beast. It can handle up to 5,000 users at any given second, or concurrent users. Ideal for up to 100,000 users, but can take a cautious maximum of 600,000 users per month, assuming again that your per second load is not more than 5,000 at any given time. It is easily scalable and can be set up to auto scale. The DB has a standby replica, the main server goes down and the standby comes up automatically. So what kind of websites you can support with this? Again, SaaS websites or apps with high activity, or websites or apps that can easily scale and have a good level of engagement. This is going to be definitely costing a bit more, so the cost is going to be somewhere around $400 to $700 per month. You can find the link for AWS cost calculator with use case 3 name in the description. Do subscribe to our YouTube channel. Bye for now.